Greetings everyone. We are from ASHRAE Mate, and this unit that's developed is IoT based refrigeration and heat pump test rig. We were provided the grant from ASHRAE for this unit. The climate in India is winters and summers. It's in winters it approximately reaches 0 degrees. It's in the northern parts of the country, and in summers it reaches approximately 40, 46, 47 degrees in the summers. So there's a need to develop a test facility which can run in both in the summers and the winters as well. And to make it easier to access, we've embedded IoT in this part. This is the evaporator, this is the condenser, and the compressor and the four-way reverse valve are situated on the behind the unit in the cooling mode. So once you've plugged in the power from behind, you need to make sure that this four-way reversing valve is in the position you want to run. Case 1, we are running it in the cooling mode and manual mode right now. So this should be in the off position. Four-way reverse valve switch should be in the off position, that is upwards. Similarly, the refrigerant flow sensor should be in the cooling mode to get precise readings. So to start this unit, this is the first caution, that these two switches should be in the above position, and the next thing would be to make this switch in the manual mode. Both these switches should be in the manual mode because we are running in the manual cooling mode, and then we'll switch on the compressor, and we'll switch on the dial indicators. As you can see, all the readings are available here, and we've started the unit in the cooling manual mode. This unit has started, but the compressor is still not switched on. When it takes approximately 3 minutes to switch on the compressor. That is a safety feature provided by the manufacturer to protect the compressor and the devices, elements put in this, and the sensor as well. So once the compressor begins, then this compressor input power unit reading would be approximately 1250, and so you'll come to know that the compressor has started. Let's wait for 3 minutes and then we'll resume. We have 4 fan speeds available. Speed 1, that is 2.2 meter per second. Speed 2, that is 5.26 meter per second. Speed 3, 6.36 meter per second. Speed 4, 6.73 meter per second. So you can adjust it according to your readings, and the same thing you need to mention in that laptop on your software as well. So as you can see, the unit is running. The compressor takes approximately 3 minutes to start, and that is for a security reason, that there is no mishappening there. In case you switched it from the cooling mode to the heating mode or vice versa. So this is the whole setup here. And to begin with, we have compressor. Once the compressor turns on, you will have a good input power here, and we can see that condenser evaporate motor input power is visible here. So I'll just wait for the compressor to turn on, and then we'll get back to you. This is the temperature sensor, which has a little bit of wooden covering outside it, and this is the relative humidity sensor. So this sensor is currently at the T11 position, that is being also depicted here. Similarly, a same relative humidity sensor is also positioned here, and in the various positions available. Here is also one temperature sensor available, and also we have about 2 dial gauges here. One is for the compressor pressure. These are the compressor pressure gauges, suction and delivery, and we also have a few LPHP cutout, low pressure and high perily overload protection switches. These are available here, and this is the IoT control switch box. Through this, the IoT mode is accessed. The refrigerant being used is R32, and in the cooling mode operation, the refrigerant flow would be from the condenser. The refrigerant goes to the capillary tubes. From the capillary tubes, it goes to the evaporator, and from the evaporator, it goes to the evaporator pipe in the four-way reverse valve. And then it regulates to the suction pipe. This regulates to the compressor, and then it flows out to the discharge from the compressor goes to the four-way reverse valve, and then it's directed to the condenser pipe, which is again connected to the condenser. This is the ideal flow of 3, 2, 1, go. So the four-way reverse valve is a solenoid operated valve, and once it gets energized, when it gets the current flow, it switches positions from this to this. So in the current cooling mode, the connection, the suction pipe remains the same in both. The discharge from compressor and the suction pipe are constant in both the modes. For the cooling mode, the flow is from the evaporator pipe to the condenser pipe, and for the heating mode, the flow is from the condenser pipe to the suction pipe. This is the only difference in both the variations of the four-way reverse valve. So I'll explain the heating mode also right now. From the refrigerant from the condenser flows to the condenser pipe. From the condenser pipe, it goes to the suction pipe. Then from the suction pipe, it goes to the compressor, and from the compressor, it goes back to the discharge from compressor line, and then in the four-way reverse valve, it is differentiated to the evaporator pipe. From the evaporator pipe, it goes to the evaporator, and then it flows to the capillary tube and again back to the condenser. So this is an Arduino Uno, and we have connected the relay at the 4, 5, 6, 7 positions. And so what is the use of Arduino Uno in this IoT box is that all the sensors in the unit are connected to this Arduino, and through this Arduino we are processing the temperature sensor inputs and outputs to the relay. So this relay is used to switch on and off the unit, and all the other operations being done in the IoT mode are being controlled through this Arduino Uno, which is then connected to a Wipro plug, which provides us the interface for the application and ease of access from anywhere. If the Wipro plug is connected to the device in the unit, then the device can be accessed through anywhere, and it provides the ease of access. That was our target problem statement. This is the power supply unit that we have used in our input, and this is used to power the unit. In addition to this is the ESP module that provides Wi-Fi access to the Arduino. These two are used together to make it Wi-Fi enabled, and this is the Wi-Fi, Airtel Wi-Fi, that is being connected to the unit, that is being connected to the Wipro plug so that it gets access to the Wi-Fi. And in addition to this is a DHT22 sensor, which helps in detecting the temperature of the surroundings. We can see now the compressor is on, so we are getting reading near about 1200 watts. So currently it's 1273 watts. The fan speed is on the second one, and we have a good flow here. To take readings, it is suggested to wait for at least 20 minutes so the readings stabilize here and you can get a more precise value. Readings are also being stored in this unit, connected via the USB to the laptop, and it is also being saved there, so you can also save your file over there. This is the possible options. We are currently running it on manual mode, manual heating option. So both the dials, both these switches are down. The refrigerant flow sensor is turned to the heating side, which is downwards, and the four-way reversing valve is also downwards, which suggests heating mode. We have various sensors available here. And so starting with the P1, that's compressor suction pressure, that is available here. All these units are written here in kg per centimeter square. And P2 is compressor delivery pressure, P3 is condenser inlet pressure, P4 is condenser outlet pressure, P5 is before expansion pressure, P6 is after expansion pressure, and P7 is evaporator inlet pressure, P8 is evaporator outlet pressure. And while switching to the temperature options, we have T1, that is compressor suction pressure, that would be the channel 1 here. T2, channel 2, that would be compressor delivery temperature. T3, condenser inlet temperature similarly, and T4, condenser outlet temperature. T5, condenser inlet air temperature. T6, condenser air outlet temperature. Just the caution that you need to mention is these two switches, this and this switch, need to be on the same side. If it's in the heating mode, both the switches would be downwards. If it's in the cooling mode, both the switches would be upwards. And please make sure when you're switching modes that you are waiting at least for 10 to 15 minutes. Only then you switch the four-way valve position and also the refrigerant flow sensor position. You can wait for 20 minutes so the reading would stabilize and take the readings down. And the next thing that you can do is currently switch the fan speed and wait for another 20 minutes to stabilize the readings and take the readings down. This is the complete working in the manual heating mode of this unit. For next thing that we'll be doing is we'll be running this unit in the manual mode but in the cooling option.